Mabuhay! And welcome, curious minds, to an exploration of the fascinating world of mathematical logic, where we will unravel the mathematical logic. In the next few minutes, we'll delve into the essential concepts and principles that form the backbone of mathematical reasoning. So hold on to your breath as we will move on to know and to dig deeper to what is mathematical logic. Mathematical logic is a systematic study of formal systems, the structure of valid reasoning, and the relationships between mathematical statements. It is the language of precision in the modern world of mathematics. Well, hap, and we will get to know the propositions, connectiveness, and truth values. And its core, mathematical logic involves propositions, logical connectiveness like and, or, not, and the evaluation of truth values. And let's unravel the basics of the logical tapestry. One of the core elements of a mathematical logic is a statement or proposition. So sit back and relax as I will explain to you this topic and give you some exercises about it. Statements and propositions in mathematical logic are declarative sentences that are either true or false. Simple or complex statements are commonly represented by symbols for logical operations. A simple example of a statement or proposition in mathematical logic is the sum of 2 and 3 is equals to 5. In symbolic notation, this statement can be represented as 2 plus 3 is equal to 5. This proposition is either true or false. In this case, it is true because the sum of 2 and 3 does equal to 5. In mathematical logic, propositions are fundamental elements that can be combined and manipulated to form more complex statements, and they serve as the basis for logical reasoning and proofs. Let's move on to the second core element of a mathematical logic, and this is the conjunction. In mathematical logic, a conjunction is a logical connective that represents the operation of and it is denoted by the symbol like this. And it is used to combine two or more propositions in a way that the entire conjunction is true if and only if all of its constituent propositions are true. For example, if P represents the proposition it is sunny and Q represents it is warm, then the conjunction P and Q represents it is sunny and warm. The truth value of P and Q is true when only both P and Q are true. So symbolically, the conjunction is expressed as P and Q. Well, traveling on to our third important elements in a mathematical logic is the disjunction. In mathematical logic, a disjunction is a logical connective that represents the operation of OR. It is denoted by the symbol like this, and it is used to combine two or more propositions in a way that the entire disjunction is true if at least one of its constituent propositions is true. For example, if P represents the proposition it is raining and Q represents I have an umbrella, then the disjunction P and Q represents it is raining or I have an umbrella. The truth value of P or Q is raining if it is raining or I have an umbrella, or if both statements are true. So symbolically, the disjunction is expressed as P or Q. Moving on to our third step of the core elements of a mathematical logic is the negation. In mathematical logic, a negation is a logical operation that represents the denial or opposite of a proposition. It is denoted by the symbol like this or like a minus, read as not, and it is used to form the negation of a given statement. So for example, if P represents the proposition it is sunny, then the negation of P denoted as not P represents it is not sunny or it is not the case that it is sunny. The truth value of not P is the opposite of the truth value of a P. Symbolically, the negation is expressed as not P. Well, moving on to our fifth step for today's video is the conditional. Conditional. In mathematical logic, a conditional is a logical connective that represents the relationship if-then. It is denoted by the symbol like this, like a right arrow, and is used to express an implication. If the antecedent, the if part, is true, then the consequent, the then part, must also be true. For example, if P represents the proposition it is sunny and Q represents I go for a walk, then the conditional P right arrow Q represents if it is sunny then I go for a walk. The truth value of P right arrow Q is true in all cases, except when P is true and Q is false. Symbolically, the conditional is expressed as P right arrow Q. Well, hold on to your breaths as we're about to approach the end. Our last step for today's video is the biconditional. In mathematical logic, a biconditional is a logical connective that represents the relationship if and only if, often abbreviated as IFF or if. It is denoted by the symbol right and left arrow, and it is used to express that the propositions are true or false simultaneously. For example, if P represents the proposition it is sunny and Q represents I go for a walk, then the biconditional P right and left arrow Q represents I go for a walk if and only if it is sunny. This means that I go for a walk when it's sunny and I only go for a walk when it's sunny. Symbolically, the biconditional is expressed as P right and left arrow Q.